Okay, so this is part 4 of adding vectors. In this video, I will read one of the problems from the book and help you guys solve it. Alright, so let's start. The problem says vector A has a magnitude of 50 centimeters and a direction of 30 degrees, and vector B has a magnitude of 35 centimeters and a direction of 110 degrees. Both angles are measured counterclockwise from the positive x direction. Use components to calculate the magnitude and direction of the vector sum. Okay, so the first thing that I would do in any type of physics problem, it doesn't have to be vectors, it could be any type, is I would write down the givens, because a lot of this information is just handwriting and you don't really need that. You just need this. You could actually solve this problem just with this little tiny piece of information. So the givens. Alright, so what do we have? We have vector A, which is equal to 50 centimeters and is 30 degrees. And let's look at the picture. I already have everything set up. This is vector A. This blue line right here is vector A, and it's 50 centimeters. And the degrees is 30 degrees. Now, in this case, they didn't say whether it was 30 degrees above the horizontal or 30 degrees north of east, or they didn't say any of that, but they did say this right here. Both angles are measured counterclockwise from the positive x direction. So what that means is that you're starting at the positive x direction and you're going counterclockwise. So 30 degrees counterclockwise would be this right here. This is the same thing as saying 30 degrees above the horizontal, and it's the same thing as saying 30 degrees north of east. Okay. Alright, so then we have vector B. Vector B is equal to 35 centimeters and has 110 degrees. So this yellow line right here represents vector B. It's 35 centimeters long, and the angle is 110 degrees. The problem with 110 degrees is that you get this big mess because it's a big angle. I don't like using that, so I'm gonna solve this problem the way that I like to solve it, which is using trigonometry. I don't like using big angles, so we're gonna use a smaller angle. Instead of using 110, what we're gonna do is we're gonna find the angle that actually goes here, right here. Okay? So to find that, we know that from here all the way over here is 180 degrees. If you remember from math, this is 180 degrees. Okay, from here all the way to here is 180 degrees. So I'm going to use the calculator to find the difference. 180 degrees minus 110, which is the given angle. Oops, 110, and we get 70. So 70 degrees is what I'm going to be using. I'm not going to use 110. I'm actually going to use 70 degrees, and that's what I'm going to put down here. 70 degrees. Okay, I'm going to use this 70 to find the y component and the x component of the vector. Okay, I'm going to draw the components in pink so you guys could see. Here we have a y component. Let me go all the way up. There's a y component, and here we have an x component. Okay, this is the x component and y component for vector A. And over here, I'm going to draw the y component and the x component. This is the x, this is the y of vector B. And this is the x and y component of vector A. Okay, so to solve this problem, first we got to figure out the components. Alright, so here we go. I already did the first part of the problem. Vector A, to find the components, use sine and cosine. So let's say sine of 30 degrees is equal to, sine is the opposite over adjacent, so you need to look at the graph to do this. So opposite of 30 degrees is y. I'm sorry, sine is opposite over hypotenuse, not opposite over adjacent. I'm sorry. So sine is opposite which is y, over the hypotenuse, which is 50. Okay, so it's y over 50. That's how we find sine. I move the 50 over to the other side. We have 50 sine of 30 degrees. Make sure the calculator is in degree modes. If it's in radians, you're going to get a different answer. So 50 sine of 30 degrees is equal to 25 centimeters. So this pink vector right here, this is 25 centimeters. Now we're going to find the x component, and we use cosine. Cosine of 30, cosine is adjacent over hypotenuse. The hypotenuse is 50, and the adjacent side, we look at the graph one more time, adjacent to 30 degrees is x. So that's why I put the x here. Then I move the 50 over to the other side. Here it is, 50 cosine of 30 degrees is equal to x. X is 43.3 centimeters. So we just found the y and x component of the first vector, of vector A. Now we're going to solve vector B. Vector B, I didn't finish it, and there's a reason why I didn't finish it. Alright, so we have, I'm not going to use 110, like I said, I'm going to use 70 degrees, because it's actually easier to picture it on the graph. So I have the sine of 70 degrees is equal to, sine is opposite over hypotenuse, so look at vector B. Opposite to 70 degrees is y, and the hypotenuse is 35 centimeters. So we have y over 35, move the 35 to the other side, and now all we have to do to this problem is solve it. So, okay, let's see. So y is equal to 35 sine of 70 degrees is 32.8. I'm going to round to 32.9. 32.9. Okay, so I just found the y component of vector B, and now we're going to find the x component of vector B. So the x component is cosine of 70 degrees is equal to, cosine is adjacent over hypotenuse, so x over 35. 35 cosine of 70, let's find out what that is. 35 cosine of 70, and look what you get. You get 11.97. I'm going to 12, so x is equal to 12. Now there's one thing really quick that I want you guys to notice. The answer is not 12. The answer is actually negative 12. Okay, and I'll show you why that happens. If you come, and this is why the graph is very useful. Notice that the x component for vector B on the graph is pointing to the negative x direction. So this is where the graph comes in handy to solve these vector problems. If you would have used 110 degrees, then you would have actually gotten negative 12, but it kind of looks weird when you're solving it, so I just stick to 70 degrees, and I look at the graph, and from the graph I can tell that it's actually a negative number. So that's why I got x is equal to negative 12. Okay, but the calculator is not going to give you the negative 12 unless you put in the angle 110. Okay, so that's a long problem. Now what we need to do finally is we need to find the sum of all the x components, and we need to find the sum of all the y components. So for the first one, we said that x is equal to 43.3. So I'm going to write that down. X is equal to 43.3. And then we just said that the second component for the second vector is negative 12. Okay, that is right here. That's the negative 12. So let's use the calculator and see what that gives us. 43.3 minus 12. That gives us 31.3. 31.3 centimeters. And the y component For the first one, we have a y component of 25 centimeters. 25. And for the second one, we have a y component of 32.9. And it's in the positive y direction, so you add 32.9. Let's input on the calculator. Let's see, 25. Oops, okay, 25 plus 32.9. You get 57.9. 57.9 centimeters. So what we just did is we found the x and y components. And now that we found the x and y components, we can actually make a new graph with those values. Alright, let's make a new graph. Okay, so what do we have? In the x, we have 31.3. Okay, so we have right here in the x 31.3, and in the y, going up, we have 57.9. Okay, so we have those two measurements. The only thing that we're missing now is the resultant, which is from the starting vector to the ending vector. That's your resultant. And that is what we need to find out now, the resultant. Okay, and we do that using the Pythagorean theorem, if you remember from the other video. So this is the formula: a squared plus b squared is equal to c squared. Okay, so we have 57.9 squared plus 31.3 squared is equal to c squared. I'm going to skip a couple of steps here. So I'm going to go ahead. C is equal to 57.9 squared plus 31.3 squared. Take the square root of that, and that's going to give you your c. Okay, so I'm just going to plug all of that in the calculator. So we have the square root of 57.9 squared plus 31.3 squared. That gives us 65.8, which I'll round to 6. So we just found out that this is actually 66 centimeters. So that's the answer. That's the vector, the resultant vector, which is what initially you're looking for. Okay, and another thing, vectors have a direction, so you need to find the angle. To find the angle, use the formula tangent of theta is equal to y over x. Okay, we're gonna get the theta by itself is equal to tangent inverse of y. What did we say y was? Y is, let me see, y is 57.9. 57.9, and x is 31.3. Okay, and let's see what that gives us on the calculator. So theta is equal to tangent inverse of 57.9 divided by 31.3, and you get 61.6, which we could just round to 2 degrees. Okay, folks, so, and that's it. That's how you solve this problem. We found that the vector is 66 centimeters long, and we found out that the direction of the vector is 62 degrees above the horizontal.